This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today we're going to learn how to determine the continuity of a function using its graph. Recall that a function is continuous if you can draw it without picking up your pencil. Any place where you must pick up your pencil is called a discontinuity. Examples of discontinuities are jumps, holes, and vertical asymptotes. Let's try determining whether a function is continuous or not by looking at its graph. How about this example? Is this function continuous on the open interval from -4 to 4? Recall that the parentheses indicate that this is an open interval. In other words, we are interested in the part of the graph from where x is greater than but not equal to -4 to where x is less than but not equal to 4. That's the region between these two dotted lines. When determining continuity on open intervals, we don't need to consider the behavior at the endpoints, which in this case are x equals -4 and x equals 4. Are there any jumps, holes, or vertical asymptotes in this interval? Yes, right here, we see a jump discontinuity at x equals -2, where the function jumps from -2, 4 to -2, 0. Therefore, this function is not continuous on the open interval from -4 to 4. Let's try another example. Is this function continuous on the open interval from -5 to 0? For this function, we are interested in the part of the graph from where x is greater than but not equal to -5 to where x is less than but not equal to 0. That's the region between these two dotted lines. While you may notice discontinuities at x equals 2 and x equals -7, both of those are outside of the interval. On the open interval from -5 to 0, we can draw the function without picking up our pencil. Therefore, this function is continuous on the open interval from -5 to 0. Take a look at this example. Is this function continuous on the open interval from -8 to 2? For this function, we are interested in the part of the graph from where x is greater than but not equal to -8 to where x is less than but not equal to 2. That's the region between these two dotted lines. You may have noticed that there's a jump discontinuity at x equals -8, but that's still outside of the open interval. Remember that for open intervals, the behavior at the endpoints does not matter. On the open interval from -8 to 2, we can draw the function without picking up our pencil. Therefore, this function is continuous on the open interval from -8 to 2. Let's try one more example, and this time we'll determine continuity on a closed interval. Is this function continuous on the closed interval from -2 to 6? Here, we have more things to consider since we have a closed interval. First off, we are interested in the part of the graph from where x is greater than or equal to -2 to where x is less than or equal to 6. On the graph, that's the region between these two lines, including the endpoints at x equals -2 and x equals 6. So we'll need to check 3 criteria: whether this function is continuous on the entire open interval from -2 to 6, continuous from the right at x equals -2, and continuous from the left at x equals 6. All 3 of these must be true for this function to be continuous on the closed interval from -2 to 6. Let's begin by checking whether we can draw this function from x equals -2 to x equals 6 without picking up our pencil. We can, so this function is continuous on the open interval from -2 to 6. Now let's check whether the function is continuous from the right at x equals -2. To do so, we need to see if the function's value at x equals -2 equals the right-hand limit. In this case, f of -2 equals 2. The right-hand limit of our function as x approaches -2 is also 2. Because these values match, this function is continuous from the right at x equals -2. Finally, let's check whether the function is continuous from the left at x equals 6. Again, we need to see if the function's value at x equals 6 equals the left-hand limit. In this case, f of 6 equals 4. The left-hand limit of our function as x approaches 6, however, is equal to 6. Because these values do not match, this function is not continuous from the left at x equals 6. Because of this, this function is not continuous on the closed interval from -2 to 6. Awesome job today determining continuity on intervals using graphs.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.